background on Dell'Oro Group. We do market forecasting, market sizing on a quarterly basis for all telecommunications equipment. My area of focus happens to be on broadband access as well as home networking, but we have analysts that cover radio access network, optical networks, service provider switching and routing, enterprise networks, data center. We're only a company of, I think we're about 18 people now, but we may seem a lot larger based on our activity in press releases and things like that, but that's the whole goal. So my background, I got started in this industry back in 1997 or 8. I got started with soft switching and voice over IP. Dial-up offload was the name of the game at the time. So we were working at a startup called Salix Technologies to develop one of the original media gateways to take dial-up internet traffic off of the PSTN. And so we had one of the first IP versions of that and just continued that evolution through there. Went to voice over DSL, voice over cable, and then I translated all those skills into the analyst world, and I've been doing that now for about 17 years. So hopefully I don't get too deep into the weeds here, but I think given Larry's presentation this morning, a lot of the stuff that I'm going to talk about kind of dovetails really nicely with some of the forecasts, the larger scale forecasts in terms of broadband subscriber numbers and growth, and then the expectations for equipment purchases and investments in particular types of equipment to make use of that capacity that's being put into the network. So I want to just talk and start again at a high level, talk about what's going on here in North America from a broadband perspective, what's driving the current spending levels, what our short-term forecasts are for equipment spending, and then I'm going to go into the specific areas. We'll look at PON, passive optical networks, and fiber to the home deployments, then go look at the cable market, look at fixed wireless, and then start to speculate a little bit about how things look in the future for broadband from a service perspective, as well as a revenue perspective. So, I mean, I think a lot of this goes without saying. Usually, the forums that I'm presenting at, right? These are very technology-focused folks at Fiber Broadband Association, CES. So some of this might be very, very obvious to you, but in a different audience, this kind of stuff, they're very, very focused on the nuts and bolts and bits and bytes of equipment. So sometimes you need to bring it back to a higher level. So obviously right now, broadband remains a critical spending priority for just about all operators that have fixed line infrastructure and even mobile infrastructure at this point. Right now, I'm actually wrapping up my update to my 5-year forecasts, and I expect that spending cycle to really increase through 2026. Previously, I thought that cycle would kind of end around 2024, but what's happened with the supply chain constraints, labor shortages, all those things that have made build-outs a little bit more difficult and a little more time-consuming, plus the fact that many operators are now getting to the point where they've hit, the sweet spot in terms of fiber deployments and fiber passings, and so now they're getting out to suburbs, more rural areas where it just simply takes a much longer time to pass those homes. So logically, that pace is going to slow down, and I think we've seen already some announcements from operators where that's exactly what's starting to happen. It's not a bad thing. It's just reality, right? I mean, that's just the way the topography and geography of the country is situated. So, again, we have a subsidization environment, of course, that lends itself to these build-outs in a lot of cases. Many of these fiber build-outs have been pulled forward, and you're going to see me hit on a very key theme. We've just gotten a lot of the 2022 or the Q4 numbers in from vendors, and 2022 was by far the biggest year on record for spending on broadband equipment. So what that means is that now, if you've pulled a lot of that investment forward, that is going to kind of slow the growth of spending over the course of the next 5 years. I'm not saying that it's going to stop. It's not going to stop, but it is going to slow because much of that equipment purchase was pulled forward. And of course, all those things that I mentioned about supply chain constraints, labor, they've raised equipment costs, which have thus impacted valuations. One of the things that drove a lot of the fiber network build-outs in 2021 was the fact that the valuations for those were far higher than they were for your traditional copper network. So as you built out the fiber network, you could go out, get more funding to build. And Frontier and others are a prime example of those kind of operators that used very aggressive build-out strategies in order to fuel additional growth and more build-outs. What's interesting about all of this spend right now is that subscriber growth has been fairly static. I mean, it's growing, and certainly from 2019 to 2020 and 2021, there was significant subscriber growth as penetration rates increased. Now we're moving, it seems, into an environment of more churn. So obviously, the point at which there are DSL subscribers to pull from, that's been largely tapped at this point. And so yes, there are still certainly a lot of copper-based or DSL-based subscribers that are still there to be captured, but those numbers are going down. Obviously, cable was very successful with that in the early stages of the pandemic, and now we're seeing fixed wireless pull from those numbers or from those subscribers as well. And then fiber obviously generates numbers away from DSL in addition to that. Really, this is a chart that I think I update probably once a month. The fiber passings from the largest operators clearly continues to grow. We're now seeing an increase in new business models. AT&T and BlackRock, for example, with their joint venture. I think we're going to probably hear a little bit more about that after my presentation. But we're seeing a lot more of this, particularly in the European market, where you get KKR and others that are working with smaller operators to fund and kind of reduce the risk of the overall fiber build-out. And we're starting to see that model kind of migrate over here a little bit more so that operators can reduce the risk. And I mean, these are substantial long-term build-outs. If you have a partner to help you with that, and certainly to move into markets where you are not the incumbent provider, where you didn't have fixed plant before, then that certainly is an intelligent way to move forward with that. So we continue to see that transition. The FTTH take rates we've seen, I think Larry presented that they're around 39, 40% in rural markets where a lot of those penetration rates are significantly higher. You get an average now between the tier 1s and these tier 3 numbers of around 45% take rates. So extremely high where it's available. And so, there's this saying now that wherever fiber goes, it wins. And that will be tested over time as these markets become saturated with more competitors and choices become not as easy to make as they were before when you just had cable and maybe a DSL provider. All right, so let's take a look at and see how that translates into spend on broadband equipment. Now, in this chart, what's included in broadband equipment are DSL infrastructure and CPE, right, to connect the subscriber in the home. Cable infrastructure and CPE. And then fiber infrastructure and CPE as well. And then also fixed wireless CPE. I only track the CPE, the in-home portion of that, because the RAN is assumed to be shared across both the mobile as well as the fixed wireless infrastructure. So it's kind of hard to get a percentage of what's allocated in terms of RAN spending on what's being spent for fixed wireless. We have a report actually where we've tried to estimate that, but It's admittedly very difficult to do on a percentage basis. So just to show you what I said about 2022, you've had steady growth in spending, and then 2022 ramps up significantly. I expect that this year, just in North America, between US and Canada alone, almost $6 billion of spend on equipment this year to turn up new infrastructure and turn up new subscribers. And that's 28% year-over-year growth, which, having tracked the broadband market for now 15 plus years, I mean, that's phenomenal, a phenomenal amount of growth for a mature equipment market. You just don't see that every day. And also, you don't see that consistently in double-digit percentages. 14% growth last year from 2020 to 2021 as well. So highly unusual environment right now, obviously fueled by subsidies. And we've really only begun the process of the distribution and the flow-through of those subsidies to the equipment manufacturers who I track in these numbers. I mean, you're still talking about subsidies being distributed for the mapping, for right-of-way access, for permitting, for pouring concrete, for new pads. We haven't really even gotten to the point of this touching, OLTs and CPE to support the new fiber subscriptions. The other thing, and I think this goes without saying, really what we're seeing, I think at a high level, is complete DSL displacement across the region, right? There are very few, there's very little investment going into DSL infrastructure at this point, which is obvious. If you look, I'll just show you, DSL on CPE and infrastructure, just even in 2018, $634 million was spent on that equipment. And this year, or excuse me, next year, we expect it to be just around 100 million. And that's largely for CPE to support ongoing upgrades to, new devices. There's very little new infrastructure going into place. If you have a VDSL network in place now, that's it. You're not moving forward with that technology. That's just going to be a holdover until you can overbuild with fiber at this point. So if you think about that, you have essentially over that same period of time about a $1.8 billion shift of spend from copper infrastructure over to fiber, and presumably largely fiber. There's obviously some overbuild with fixed wireless in that situation too, but let's just assume. So even though when we talk about the fiber to the home spending right now, a lot of it is talk about expansions, edge out projects, et cetera. But there's a lot of overbuilding going on as well, and decommissioning of copper networks. In the Tier 3 space, AT&T and others have been public about the need to decommission the copper networks and pull back from those ongoing costs. So that's exactly what we're seeing happening right now as reflected in the equipment spend. All right, so let's drill down. I don't know if this is necessary, but I thought I'd put this up there just to set a baseline of what the basic, fiber to the home architecture looks like for 99% of operators in the region, right? This is fiber to the home using passive optical networks, right? So you've got, the central office, or even out at the hub where you have the OLT, the optical line terminal. And those are, each individual port on an optical line terminal is generally split to support anywhere from 24 to 32, sometimes 64 at the high end subscribers per individual port. Okay? Those individual fiber lines are split either at the splice case or punch down at the fiber distribution hub in the neighborhood. And if you've had fiber build-outs come through your neighborhood at this point, you'll see these fiber distribution hubs start to pop up. Even in situations where you have aerial fiber going through neighborhoods, they will typically drop to that fiber distribution hub so that they have easier access for the technician to come and turn up a sub or move them from a 1 gig connection to ultimately a 2 gig or 3 gig connection using a different technology. And so just the different PON technologies that are used primarily here in the North American market. Right now, the dominant technology is GPON, and that provides per individual OLT port to shared across 24 to 32 subscribers, 2.5 gigs down, 1.25 gigs up. Okay, so with the typical GPON deployment, you're looking at a maximum, not sustained rate, of course, but a peak rate of 1 gig. And then on the upstream side, you're typically not providing a symmetric service. And that's really the case of most fiber providers today, at least on a large scale. They're not offering a symmetric service. They're offering a very near symmetric service. It isn't until they start rolling out what's called XGS PON, right, which is 10 gig symmetric PON. You've got 10 gigs in both directions, and that makes it very easy to start deploying symmetric 1 gig and even symmetric 2 gig services to your customers. AT&T and Frontier are really, in the region, are the ones driving the purchases of XGS PON. And you'll see in just a minute how many new ports and how much money they're spending on XGS PON. On the cable side, there's less emphasis on fiber, although there is a growing emphasis on passing more homes with fiber. But still, it takes a backseat, at least among the larger Tier 1 operators, to DOCSIS 3.1 and DOCSIS 4.0. But they use a technology called EPON, or 10 gig EPON, which is also 10 gig symmetric. But it's an IEEE variant that allows them to basically drop it in and be managed similarly to how they've managed their DOCSIS or HFC customers for years. So it's a very smooth transition for them. So those are the three primary ones. Verizon also uses an NG-PON2 technology, which does 4 separate 10 gig wavelengths. And so they're experimenting with that. It's an extremely expensive technology because it uses coherent optics, right, or colorless wavelengths. And so on either end, those are expensive because you can either move from each of the wavelengths depending on what service level you have. So in some situations, like in Tampa, Verizon is using it. They'll use one wavelength for their residential services, another wavelength for business, another wavelength for wholesale backhaul services, and then another for their own millimeter wave backhaul for fixed wireless. So it's an interesting test case. They only buy, I don't know, maybe a few thousand ports per year just because it's so expensive. But ultimately, it allows them to flatten their entire network because they push all the routing, all the subscriber management capability into that platform so that they don't need to have any centralized subscriber management back in their central offices or their data centers. It's called the One Fiber program, and it's a very long-term transition for them, but certainly interesting from an architectural perspective. So this is the split in terms of how much spend is between the OLTs, right, the infrastructure or the switches that go into the network to terminate the subscriber connections, and then the ONTs, which are the fiber units that go into individual homes and businesses to terminate that fiber into the home and distribute it throughout the home. What you see, I think, that's interesting about this is that we're still really focused on the infrastructure build out right now. It's very heavily infrastructure focused. In years past, when you would see a fiber build out, you would have a few quarters of infrastructure build outs, then a slowdown, and basically a commensurate increase in ONTs, right, to support the subscriber connections. Well, that's not happening right now because the focus, because of subsidies and the need to get footprint out there, is on the infrastructure build out. The other thing that's making things challenging is the fact that ONTs are hard to come by. You've got everybody trying to put in orders early for new subscriber devices, and because of the supply chain issues, component shortages, those ONTs share capacitors and other components with other consumer devices. So until those supply chain issues get resolved, it's going to be hard to put in large-scale orders of ONTs. So that's why you still see a significant a significant lead in terms of the infrastructure purchases versus the subscriber units. So we still have very far to go. So some of the penetration rate numbers that Larry shared this morning, they will increase over time with the increased availability of the units to connect the subscribers. But until then, it's still going to be challenging, not only from a marketing perspective, but also from a service and product availability perspective. So I mentioned XGS-PON, and these are all the 10 gig technologies that are really being used in North America right now. But you can see, by far the dominant technology being used is XGS-PON. It's really hard to see with these, with the colors that got changed. Is this a pointer as well? Is it? Yeah, there we go. Okay. So yeah, so this is the XGS-PON growth. Really, that growth has been fueled by really two operators, Frontier and AT&T at this point. There are a lot of tier 3s that are also deploying it, but then when you aggregate their numbers, they're nowhere near the scale of those two in terms of their purchasing power. The other thing Larry pointed out this morning was, you know, he had this this number, the S curve, that showed that by 2030 we were looking at 3 gigabit connections. Well, all this infrastructure going into place in those networks can support those symmetric 3 gig connections. So if you follow that continued S curve, the infrastructure is going in now to support those speeds by 2030. And you know, I always talk to vendors because, especially vendors like Nokia and Adtran, the ones that Calix and others that are the primary providers of the equipment into the operators in this region, they always ask me, when you talk to operators, what do they think is going to drive bandwidth? Because they're concerned that, you know, this is it, like this is the build out and it's not going to continue afterwards. And the operators don't have necessarily a particular application or use case. You know, some talk about the metaverse and they talk anecdotally about the bandwidth that's going to drive. But if you look back at consumption trends, they follow this same curve of growth of anywhere from 30 to 40% CAGR per year in terms of downstream capacity. So the point is, if you build the capacity, people will find ways to use it. They will, you know, they have 4K, they have 8K, and even though compression technologies improve to reduce the amount of bandwidth that those streams need individually, the fact is traditional TV subscribers are going down. Streaming continues to go up. The demand for that type of bandwidth, even with compression, is only going to go up. It's going to be used, and it doesn't have to be a single use case. It's the aggregate of increased penetration among subscribers, and you know, just reliance on today's applications that continue to get more bandwidth intensive that will mostly drive this compound growth in consumption. And I think operators, that's what they're betting on. They know it, they've seen it now. It's now been, you know, 20 plus years of predictable growth, 2020 notwithstanding, predictable growth in terms of consumption. And that's what they're building towards, is a number at, is the usage in 2030, not the usage in 2025 anymore. And then just quickly here, I mentioned the ramp of XGS ONTs in order to be able to do a full 1 gig symmetric service into the home, and even a symmetric 2 gig service. And in some cases now at AT&T, they're marketing a symmetric 5 gig service. Bell Canada and Rogers in their fiber footprint are offering symmetric 8 gig services. So the cat is out of the bag. I mean, we love our speeds, right? And if it's important for us and we're spending time still working from home, which I think that genie is out of the bottle as well, there's always going to be a need for that bandwidth in the house. 8 gigs, maybe not, but we'll get there. We'll get there. And I just thought I'd share, just for your reference, this is how the vendors stack up, the 3 primary vendors in the North American market when it comes to equipment spend. Nokia has been the primary equipment supplier to Verizon, AT&T, Frontier, a growing number of Tier 3s. Calix has really dominated the Tier 3 market for a long time. Adtran has been a growing supplier. They've been in the Tier 2 market, CenturyLink, Lumen, and others, but they're also growing their footprint in Tier 3 as those Tier 3 operators have gotten CARES Act money, RDOF money, they'll ultimately get BEAD money, so they need an abundance of suppliers who have different supply chains in order to ensure that they're going to hit their milestones for those particular subsidies that they're getting. So what's next for PON and fiber to the home? Again, XGS-PON is the technology of the day. GPON is still, in terms of overall numbers, is still the largest share of the market, but it will be eclipsed by XGS-PON probably by the end of this year already. And after that, kind of the jury is still out. If we're looking post 2030, what's interesting about Nokia's approach, and all of these vendors now have what are called combo PON, right? So the transceivers, the optical transceivers that sit in the network can be upgraded from traditional GPON at 2.5 gig to XGS at 10 gig, and then also now, in the case of Nokia, to 25 gig symmetric, all in a single transceiver. So there are a number of operators now that are making purchases of that equipment so that it becomes a lot easier for them to go ahead and flip a switch and send you out a new ONT should you want to subscribe from, move from the 2 gig service to the 5 gig service. In the case of the 5 gig service, that is going to require typically a 25 gig connection. Nokia at this point, at AT&T, 30,000 25 gig ready ports are available at AT&T. And they're still buying now far more than that. It's just what they've turned up is still 30,000. They probably have 350,000 25 gig ready ports ready to turn up. So it's an interesting dynamic. After that, you've had kind of this bifurcation in the industry, right, between 25 gig on one side, and then the ITU is pushing 50 gig, right? So 50 gig downstream, 25 gig up is the initial version, and then shortly thereafter it'll be symmetric 50 gig, if you can think about that, being shared across 24 to 32 subscribers. And even at this point, Cable Labs, Nokia, other vendors are working on 100 gig PON. So the roadmap in terms of these technologies is pretty clear. It's all based on increased speeds. Split ratios stay the same, meaning you're not, as an operator, suddenly going to say, well, I've got double, I'm putting in 25 gig PON now where I had XGS at 10 gig. Now I'm going to split from 64 homes per port to 128 homes. You're not going to do that anymore. That's expensive to do. You just don't do that. You increase the bandwidth, reduce the cost per bit, and again, those subscribers will either pay for it or they won't. They have a choice. It's not a loss at this point because you're not swapping anything out other than the optical transceiver and the CPE device, the customer premise device. It's a very low-cost transition. So all this money that's being put into these fiber infrastructure and these deployments now, there's a roadmap for increasing bandwidth with limited touch on behalf of the operators. So it's a very ideal situation for them in terms of valuations and increasing value of those networks over time. Okay, let's switch gears and talk a little bit about cable. You know, cable operators have obviously dominated in terms of subscriber numbers in the North American market for years. Most, if not all, are at DOCSIS 3.1 now. A good percentage of them have a very clear roadmap now, which gets them to multi-gig symmetric services as well. The plan for Comcast, Charter, Cox, and others is within the existing DOCSIS 3.1 plant. You do what's called a mid-split or a high split, meaning you allocate more of your available bandwidth to the upstream side, okay? And that solves the problem and the weakness of DOCSIS, which is more bandwidth downstream and very asymmetric upstream side. And that was something that they're starting to get hit on, but really, from a consumer perspective, we don't use a whole lot of upstream bandwidth. We're starting to use more, but we really don't. And so that growth rate, the downstream, when we talk about like the 40% CAGR in terms of bandwidth consumption, that's all on the downstream, you know, the data that's coming to you. Your requests for information or your uploads of videos and pictures and, you know, use of cloud services, Zoom calls, et cetera, haven't added a significant amount of new headroom required for upstream bandwidth. So that's something to keep in mind as they upgrade. They understand that they face a liability on the upstream side when a fiber provider comes in and says, we'll offer you a symmetric 500 gig or 500 meg service. And they're at 500 megs and 35 megs up. So it just looks like a very lackluster number, even though the billboard speed is that downstream number. Still, it's necessary for them to upgrade, and it's also this process of going from 1 gig down to 35 meg up to 100 meg up is really inexpensive. We're talking about changing, changing tuners at the optical node, right? Which they typically serve anywhere from 300 to 500 homes, and that's a very simple process. We're talking about maybe, you know, less than a couple dollars per home passed, if that. And so cable operators can get to, you know, a 1 gig and near symmetric service for very little cost. And then as they do that, they set themselves up for the ultimate transition here, which is just now starting, which is DOCSIS 4.0. And there are two paths to DOCSIS 4.0. Comcast is pursuing a path that's called full duplex, right, which moves all of their outside plant to 1.2 gigahertz. But it will get them to symmetric multi-gig services. However, it requires upgrading all of their amplifiers, the CPE, and taps with echo cancellation technology, right? Because you need to, if the pipe, just like if the pipe is allocated as just a single pipe, you need to have some way to designate the upstream side versus the downstream side. But in that situation, it gives them flexibility over time to say, okay, maybe you don't want a symmetric 2 gig service, but you want a 3 gig service down and a 1 gig service up. With echo cancellation technology in that outside plant, they can do that for you. So it becomes very interesting. Charter, on the other hand, is pursuing a model called extended spectrum DOCSIS. Instead of going to 1.2 gigahertz, they moved to 1.8 gigahertz in the outside plant. Okay, so obviously more spectrum, more bandwidth available to you. And that's something cable operators know. They know how to do this. They've done it from 500 meg to 750 megahertz to 1 gigahertz and now to 1.8. No change required in the amplifier spacing, which is usually a big and costly endeavor. No change really to the technology of amplifiers other than to pump out more spectrum. It certainly will require new CPE in the home. That's a given for all of these technologies. But in both cases, whether you follow the Comcast path or the Charter-Cox rest of the cable world plan, it's going to get you to 5 gig symmetric services without running fiber to the home. And I think that's critical because we're talking about a total cost from end to end of around, let's say, $200 per home, not including the CPE, which is probably another, in volumes is probably another $75 to $80, per home. So when you compare that plan to trying to pass a home with fiber and connect a home with fiber at anywhere from $1,500 to $4,000, $5,000 at the high end, I mean, economically it makes sense. The challenge, of course, for cable operators is the perception issue, right? That they're the incumbent, coax isn't fiber, and that they're just going to have to face that challenge and find new ways to market the service that says speeds are the same. There isn't any difference. Plus, we're the ones that are experienced providing you broadband. You may not have liked us when we were your TV provider, but we've been a solid broadband provider for many years for you. All right, so a big part of this transition is the move to what are called distributed access architectures. So in cable networks, the optical node was typically a very layer 1 device, very basic, right? Its whole function was to take in an optical signal, translate it to RF, distribute that RF to you and I as cable broadband and cable TV subscribers. Well, in this distributed access architecture, you're now taking part of the intelligence of the network in terms of layer 2 and layer 3 capabilities, some routing, some subscriber management capabilities in some cases, but also just basically moving that into the optical node to make that more intelligent, and then also be able to deal with subscriber issues and understand subscriber issues at the node rather than as a service outage that impacts all of your service groups. All right, so they can isolate these faults much better and to maybe a group of a couple hundred homes as opposed to a system of tens of thousands of homes. So these purchases are extremely important as they move down that road. The other thing that these devices do, and there are two options here, right? Remote PHY, which basically takes the physical layer of the traditional CMTS, which is the primary routing platform that cable operators use in the DOCSIS broadband scenario, and puts it out into the node. And then remote MAC-PHY, which basically takes the whole function of the CMTS and moves it out into the optical node. There are benefits and costs to both, obviously. But in both cases, the biggest thing that both of these platforms provide is a transition to digital optics and Ethernet transport out to these nodes. Before, they were analog optics, right? Those aren't, the growth pattern for those, as well as modulation and signal errors, were always fairly high. So now you get rid of that, and plus now you have the ability from that end to move from 10 gig to 25 gig Ethernet to 50, 100 gig, whatever. Now you're following a different cost curve on the transport and backhaul of those optical nodes than you were previously. So that changes the dynamic for cable operators as well. So you can see Comcast is really driving these numbers right now. They're the ones that have been the most aggressive. I think they've passed 50,000 total nodes upgraded with remote PHY at this point. So Charter just recently announced a strategy shift. Charter was originally going to do remote MAC-PHY, and they were waiting and waiting. Vendors and Broadcom were really being difficult in terms of providing the necessary components for those platforms. So Charter shifted as of December to Remote PHY, which makes sense. It also makes sense for the industry. Vendors don't have to maintain 2 product sets. They don't have to send development or allocate development for both product sets. They can focus on Remote PHY at the hardware level and start taking orders for those platforms now. So over time, beginning probably in later this year, but mostly in 2024 and beyond, Charter will add a significant amount. Charter has more nodes in their network than Comcast does because of the service areas, reduced service group sizes per node, all those elements. So that'll be a big jump in this particular market. Now, I mentioned that cable operators are doing a little bit of fiber, and those are reflected in these numbers here, remote OLTs. If you go back to the last slide in Remote PHY, the little Remote PHY discussion that I had, in these optical nodes, you only have so much power to these nodes, right? Usually 100 watts, maybe, or around that. If you're upgrading to Remote PHY, it's a module that goes into the existing node. Remote OLTs, it's a very similar module that goes into that same node. Now you have enough power, you can continue to deliver DOCSIS services over HFC to your existing customers, obviously with the benefit of the improved signal quality. But with the remote OLTs, now you can start to peel away fiber to the home subscribers. It's not a big cutover. It's not a flash cutover where you've got to say, I've got to overbuild now my HFC plant with fiber for 5,000 homes. I can do it for 32, 64, 128 homes. And I can start to create service groups that are fiber-based that might be, let's say a brand new neighborhood is being built across the street from an existing neighborhood. You're obviously going to use fiber in that greenfield scenario. This allows them from that same optical node location to start delivering fiber where they need to. And this is kind of a secret product that is starting to grow in numbers. You look at, relative to XGS-PON, we're talking about a drop in the bucket. But this is how cable operators, Charter is one in their RDOF build, they're going to rely on this as they do edge outs. This is a perfect platform for that. They can manage those subscribers the same way they do existing DOCSIS subs. So it's a no-brainer for them. If they are being forced to move to fiber faster than they want to, they can respond now. The last thing I'll show here in the cable section is virtual CMTS. We talked about O-RAN on the wireless side. We're already into virtualized open source platforms in the cable broadband market in terms of the management of subscribers, in terms of the provisioning of services. And Comcast is really driving this now as well. But you can see over time, as the bandwidth demands with DOCSIS 4.0, you have more capacity required, you're going to continue to add those via servers and not big iron hardware platforms anymore. So once again, the cost to scale for those multi-gigabit services for cable operators is extremely low. We're talking about a price point of, on a per channel, DOCSIS channel basis, which was 42 megs, right? 6 gigahertz, 42 megs of bandwidth. Each one of those probably costs now $30. And that's shared across, obviously, a service group. Whereas before, if you look back historically, way back when, it used to be $10,000 per downstream. So that price has come down considerably over time. So what's next for cable broadband? I think I've already gone over a lot of this. I do think there will be more cable fiber build-outs than expected. I think the market is just kind of forcing them in a lot of cases strategically to respond. They don't necessarily want to, but they can. And now they have the technology at their disposal to go ahead and do that. Again, though, for the vast majority of subscribers in a Tier 1 cable operator environment, they're going to follow this path to DOCSIS 4.0. really because of the cost. I mean, it's a significantly lower cost to pass and connect a home than it is for fiber. And of course, that's how cable operators have managed to do so well over time, and that's how they'll manage to do extremely well still from a subscriber growth perspective, but also from a cost per bit perspective. All right, fixed wireless. I don't know if I need to really go over this. We've had good discussion about T-Mobile, but for me, I mean, it's very clear in talking to the cable vendors and also the cable operators, you know, publicly, they were very dismissive of fixed wireless as an option. They said it's an inferior technology. And now that they're kind of getting their asses kicked in terms of subscriber numbers right now, they are coming back to the table and saying, well, you know, it's a difficult subscriber environment, I think is the latest, the way to describe it. Really, I think the timing for T-Mobile and Verizon, but primarily T-Mobile, of going after a value play, going after subscribers, you know, post-COVID, has been wildly successful. I mean, you look at the growth, and we mentioned the numbers, the growth has been sustained and significant. So you have to hand it to T-Mobile for hitting the market at the right time. Macroeconomics have something to do with that, of course, but I think pricing it at $50, which is well below what cable operators price their service at, which is typically, you know, $69, $79, that much for service, even if it's not faster speeds, it doesn't matter. People are concerned about their bottom line right now, and I think that's where they've been successful. All right, step back from T-Mobile. When we look at fixed wireless, really in the region, it's really two separate markets. You've got the 5G, the 3GPP technology-based operators like T-Mobile and Verizon and AT&T. And then you've had the more long-standing fixed wireless providers, WISPs, wireless ISPs, that have been doing this for a long time using unlicensed spectrum, usually proprietary 802.11 technologies. And they've covered a lot of rural areas, a lot of unserved and underserved areas. Well, you know, now the WISPs are facing kind of a change in their business plans. BEAD money says that unlicensed spectrum can't be considered. So therefore, whatever service they were using before can't be used for BEAD subsidized rollouts. So they either have to go and get some licensed spectrum. A lot of them are supplementing their existing service with CBRS spectrum where they can, lightly licensed CBRS spectrum, or they're simply just moving to fiber. So we see in the case of many wireless ISPs, that's it for them, right? They're not moving forward with any next generation service. They're going to use money to build out fiber and focus on that going forward. So that's why you have growth coming from the larger providers now, and then in the WISP market, you're not seeing a whole lot of growth at this point, and you're frankly seeing more of an existential concern about how they move forward. So we look at the CPE units, and so I forecasted these based on the different type of technologies that are being used for fixed wireless. Clearly, because of the growth at T-Mobile and Verizon, it certainly makes sense that the 5G sub-6 numbers are the highest right now and will remain the highest over the course of the next few years. Really, you know, T-Mobile had started with the Nokia units and has now moved to Arcadian units because of the cost associated with them, and obviously also because of availability of the units. So, you know, my expectation for the fixed wireless market is that you're going to continue to see growth through 2025, and then I think you're going to see things moderate a little bit. The concern around capacity issues, while I think there's there's a split camp on those as to whether that's really an issue that limits overall growth over time. I do think that has a role to play because given finite capacity and if the spectral efficiency gains don't come as quickly as they need to, who are you going to allocate that spectrum to? Mobile subs or fixed wireless subs? If you have to make a decision, I think you probably allocate it more to mobile subs. But that's still something. Technology always improves. There's always ways to do modulation to improve spectral efficiency. So it's hard to base a forecast based on capacity issues per se. Certainly, we're not going to see a whole lot of growth from the WISP market going forward, so kind of take that out. There will be some, I think some cooler heads will prevail. I think in terms of subsidization, right, we're talking about getting people connected. It doesn't have to be fiber necessarily, especially if you've got a timeline to get all these underserved and rural communities connected. Why not use all the technologies at your disposal? And I think over time, there will come a realization that you just can't get fiber everywhere. It's not realistic, no matter how much money you throw at it. And so there have to be technologies that allow them to get the connectivity without the necessary costs, even if it's subsidized. So I think that's going to keep the fixed wireless market, particularly in the US, continuing to grow. And I mentioned, slowing subscriber growth. That happens, right? That's that S-curve. We've just seen phenomenal growth coming from fixed wireless over the last year, and I think that's going to continue very easily through the end of this year and into 2024. At some point, though, cable operators fight back with their DOCSIS 4.0. Fiber providers are going to push hard because they need to show a return on investment. So I think they're going to have to compete at some point with the price points that fixed wireless offers, and so the capacity constraints perhaps become an issue, but we'll see. So I think fixed wireless over a longer period of time. I think in the short term, again, strong growth potential for subscribers, and then over time, I think it's going to be really tough to compete with fiber and DOCSIS 4.0. That being said, for broadband, it's interesting because we've had so many markets in the US where there's been zero competition. There's typically been one legitimate broadband provider, meaning one that can provide a service that's meaningful, particularly during COVID, right? People realized that when you're at home and you have certain speed requirements, there was really only one option. And DSL was not that option. So people moved en masse over to cable and whatever fiber technologies were available to them at the time, and hence the current fuel for building out, or one of the reasons for the build out. I think there is a bit of some exuberance in terms of the fiber build-outs. I think despite all the mapping and all the money that's going into mapping, I still think you're going to find communities that have a fiber glut. It's just natural that in edge-outs and overbuild scenarios that it's bound to happen. I think that results ultimately in some additional M&A activity over time. I can't remember, Steve or somebody mentioned the fact that cable operators are mobile operators as well. And that bundle is so important. The fixed and the mobile bundle is going to be critical. And I think it's not only because you capture a subscriber's full wallet, but I look long term and I look at my kids and I see them all with phones and mobile devices, and I wonder about the long-term sustainability of fixed broadband. If push comes to shove, do they become broadband cord cutters, right? We saw this with TV. If you only have so much money to spend each month and you're paying $100 per phone and you're getting great data connections with that, is it possible that you will forego a fixed broadband connection in your apartment or your dorm or maybe even your first home because you have everything you need in the palm of your hand with a fixed wireless connection or a wireless connection? So I always think about that and the impact, but clearly operators think about that as well, which is why they need to be on both sides, right? And that's why that bundle is so critical. And the last thing is, I think as we have more competition in these markets where we didn't have it before, operators have to differentiate on new services. I mean, we've talked about that for a long time. Managed Wi-Fi, I mean, I think the jury is still out on whether that's a true incremental revenue service, a revenue generating service. I think it can be. I think if it's bundled with things like cybersecurity, parental controls, I think cloud storage is an option. If you bundle those kinds of things, that really helps to cement that relationship with the subscriber. And then the other thing I think I hear more about is, you know, with more people working from home and still kind of splitting time even in a hybrid work environment, offering tiered residential services with higher SLAs if you want to pay for it, like a business light type service, where, you know, you get faster response time, guaranteed response in terms of network outages. Those are also options. So I think those things have to be on the table, particularly in competitive environments, which we haven't had in a lot of cases. So it's going to move from just being a bandwidth game to being a customer service, reduced latency, bandwidth on demand, really customized and tailored to what the individual subscriber wants. And I think the interesting thing is that the technology is going into place now in fiber networks and in cable networks to support those kind of services. It was not there before. The flexibility to go ahead and make a change across the network from the core of the network to the subscriber's endpoint was never there before, and it's there now. So I think that's what's different. So I think that's it. So I hope that was meaningful and useful. I guess I'm happy to take your questions. That's it. So I hope that was meaningful and useful. I guess I'm happy to take your questions.
Questions?
So I saw your quote in, I forget which, light reading today or yesterday.
Oh, there was. Okay.
On XGS-PON, what percent of the U.S. market do you think XGS-PON will be shipped this year versus GPON?
I think in terms of new infrastructure, new OLT ports, it'll likely be probably 65% XGS-PON this year. Now the ONTs are a different story. We're still waiting for the lower cost XGS units to start shipping in more volume. We're starting, I think, I just looked at Nokia's shipment numbers for this quarter, and I think they were at maybe a couple 100,000 units. So still.
Okay. So the XGS-PON ONT units will be delayed a number of years as the other infrastructure gets deployed. Got it. Okay.
Yeah, yeah. I think they'll ramp up pretty quickly by the second half of this year. Okay. But you still need, there's still some, there are manufacturing facilities in China and Taiwan that are still understaffed and still just catching up.
Let me ask a follow-on question if I can, real quick. So with the BEAD bill focuses on Buy American.
Yeah.
On the ONTs, OLTs, from what I am aware of, those really can't be manufactured in the U.S. Is that right? For the most part.
They can't be manufactured in the U.S.
Can't be manufactured efficiently in the U.S. because of the chips.
Yeah, they're just it's too expensive. I mean, you're trying to get to a price per unit of, you know, $50, $60. Yeah. And the transceiver cost alone is probably 30 or 40% of the total bill of materials cost. Okay. So yeah, there's not a lot of flexibility. The labor is the biggest piece.
We We have an online one from Bill Kleinbecker. Do you see the new options for going to the home and ability to upgrade the data rate will move the creation of a metaverse group, DAA, with the streams managed, the optical node, which will be driven by Web 3.0, distributed data lakes, more pandemics, metaverse, and hospital at home use cases. Also, the impact of streaming to the home, which would eliminate VCR with higher access to content at any time of day for multiple home occupants, etc. Also won't have to send text to the home if done with full duples to the home.
Absolutely. I mean, I think all of those are on the table, and it will, I think it'll just take time. I mean, especially in the case of distributed access and the transition from optical nodes to DAA nodes. Keep in mind that cable operators have had those in place for decades. So it's also, it's a talent shift and an organizational shift as much as it is a technology shift. And that takes time, right? I think, an operator like Comcast made that decision to become a software developer and standards contributor years ago, and is just now to the point where they have the kind of IP and Ethernet and higher level coding expertise in-house where they can do that. I don't think many other cable operators at this point can say that. But it was all, that decision was all one about continuity, business continuity for them. They knew if they were going to pull these talented engineers who want to go work for Meta and Google and Amazon, and they're doing things in the cloud, they had to have something that was equally attractive and followed and used the same types of protocols and architectural definitions. So that transition is still happening. You still have plenty of folks that have to understand RF and DOCSIS and testing of signal and noise leakage and all of that stuff. But over time, yes, it's all going to move in that direction. Every cable operator will be different as to how quickly they make that transition to moving workloads into the public cloud. But whatever makes economic sense, they will move in that direction and take advantage of it.
Jeff, got a quick question on one of your early slides about fiber builds. I'm not in the fiber business, being a pure play wireless, but can you give a little more color on one of the carriers that wasn't mentioned on that slide that happens to be Verizon?
Yeah, so Verizon obviously was first out of the gate with FiOS way back when, and they've really slow rolled that rollout and have basically committed to not expanding beyond their existing territories. Now they've more recently come out and said, yeah, we're going to add additional footprint within those serving areas, but they're not moving outside of any of those regions to expand significantly. And the purchasing decisions in terms of equipment really reflect that fact. So it'll be interesting to see. They sold off a lot of the properties to Frontier and others that they didn't want to deal with anymore in terms of having to do DSL upgrades. I think they're going to rely in the future on a combination of fixed mobile and that existing FiOS footprint in order to create a bundle of different options for customers in those service areas. But I don't see them making any additional major expansions. Mm-hmm.
Thank you, Jeff. I have a question myself.
Oh, okay.
I'm not trying to close things off. I was thanking you in general, not for in the presentation. I had a couple of questions. You mentioned mobile cord cutting. At what point can we go to do mobile cord cutting? 1, 2, 5%, 10% before you run into capacity problems you were mentioning that fixed wireless would have?
Oh boy, that's a great question. I don't have a clue. I really don't. I haven't modeled that. I don't know if the operators are, if they're willing to share that
Sure.
at this point either. So we'll
Right.
continue to talk to them and figure that out.
Yes, that's, it's an interesting question, though. I think this, because we do have limited capacity networks, and we'll probably get there. The second question I had is this is as a rule of thumb for, you talk about a 1 to 2 gigabyte PON system, and say 64 customers on each of that say 1 to 2 gigabyte channel, gigabit. What does that translate to in terms of the advertised and actual data rate that this is for each subscriber gets individually? Is there a rule of thumb for going from?
Yeah, I don't recall offhand, but obviously they're only obligated to peak to the advertised billboard rate, right?
Right.
That's not a sustained number for them. But I don't remember offhand what the functional usage of bandwidth. You'd be surprised at how low it actually is, if I recall. I mean, I think it's in the single, maybe low double-digit megabits
Yeah,
on
if you divide
average,
by
if you think
64,
about it per house, right?
Yeah.
Because it's really a limited amount, even when people were working from home. And then in the primetime hours, then it shoots up, right? So you really just need to have the capacity to handle the peak usage, just like you did back in the days with telephone calls. Like you architected the network for Mother's Day, right? Or Super Bowl, and now TV for Super Bowl Sunday, and broadband is kind of the same thing.
Okay, so, but do they advertise like a gig service, or do they advertise 100 megabits per second service? What do those carriers advertise?
They can still advertise a gig. If you do a speed test, then you should get a gig,
Most of the
right?
time you will, okay.
That's the goal, right? And that's why with this XGS PON, these ONTs, one of the additional costs associated with those is moving to 2.5 gig LAN ports, and now in some cases 10 gig LAN ports, so that speed test issue doesn't happen. You know for a fact that they're always going to, if they plug directly into it, they're going to get the speed that you've advertised.
We have another question. I actually just posted it up there. Interesting numbers. This is by Bawambra Chikowa. Interesting numbers on slide number 23 on $200 per home versus fiber, $1,000 at home. Are you able to shed more light on this?
Yeah, I think that was the comparison between the cable DOCSIS 3.1 upgrade cycle to DOCSIS 4.0. And that has been mapped out using the existing architecture of amplifiers and taps at anywhere from $200 to $300 per home, depending on the topography of the neighborhoods. And I think they've been pretty public with those numbers, both Comcast and Charter at this point, as they've rolled out their plans for DOCSIS 3.1 and 4.0. The fiber to the home number obviously swings wildly, from a rural area, suburban area to an urban area. Clearly it's at the lower end of that $1,000 to $2,000 range, but I've talked to plenty of rural operators who said we would never do this if it weren't funded, because we would be easily at $4,000 per home passed. It would not make sense if we couldn't cut that price in half with the subsidies. Yes?
And maybe a follow-up to that 1,000 versus 200. 1,000 was...
One second.
Can you hear me okay? Yeah. The 1,000 was if a cable company were to upgrade using fiber, or is it any telecom would take it to fiber?
I think it's a general rule of thumb, yeah.
Okay, so and then it's really not just the capital costs associated with the fiber to the home versus an upgrade to 4.0, because there is operational cost differences between the two, where you continue to have to power the hybrid fiber coax system.
Yes.
There's still the life limitations on the coax. there's still this market perception of that it's not as good as fiber, so the penetration rates are not going to be as high for that 4.0. But and I guess is 4.0 really is it future proof, right? And it seems like that it's not, and that really realistically, only if you go all the way with fiber to the home is that future proof. That's one kind of get your thoughts on that. You agree with that?
I mean, I agree long term. And once you get fiber into the ground, how your speed is determined by the electronics at either end. You're not worried about amplifying a signal anymore at that point. Maybe you have to change out passive, AWGs or splitters of some kind, but that's a relatively low cost because, like you said, there's no power going to those. They're passive devices. So you're absolutely right. I mean, if you're just comparing apples to apples of the cost to pass a home with the same equipment, then yes, I mean, fiber's far more expensive. But over time, with the operational costs of powering amplifiers, failure rates of active electronics in the field, that changes the equation. But I'll say this though, in talking to the three major cable operators, they all talk about the fact that if they're upgrading now with these next generation amplifiers and node housings and things like that had far more intelligence than they did before. Doesn't take away the fact that you still have to power them. That's still a cost they have to bear. However, failure rates, which were high on amplifiers, and noise, egress noise and ingress noise from those active electronics are going to be reduced significantly, so that in their thought, the time that those elements were still in the network was going to be quite a bit longer. Now, to that point, though, you still have to deal with the fact that the perception is that it's an inferior technology because it's not fiber. Right. So now you see them marketing, I think, fiber, like Fiber Light or fiber. They're putting fiber into the name of their broadband service somehow in order to make sure that the perception is there. And we'll see how that pans out. I don't do the marketing side of things, but we'll see.
Hey, Jeff, one more follow-up question. I know you've been at this in a while, so you've been talking about your forecasting and some of the things.
Yeah.
Looking back the last few years and maybe looking forward also, have there been any oh shit moments the last few years where you didn't see that thing coming or that piece of technology that got adopted? And going forward, are there any dark horses or some fringe technologies that could upset the apple cart, so to speak?
I will say that the strength of the fixed wireless market has been really surprising. I mean, coming from the larger operators, I think that was that's been interesting to see, and something that we didn't really forecast before. We knew T-Mobile and Verizon had plans to allocate some of the spectrum, but we thought it was going to be, a lot more limited than it has been. And I think the aggressiveness of which the service is being marketed, also the timing just of the economy and people's budgets being squeezed and needing to find a lower cost solution, that also helped. Looking forward, I think the other thing that's changed is the adoption of 10 gig or XGS-PON. I mean, that's happened extremely fast. Even to the point where, the operators are willing to bear additional cost for the transceivers and the line cards in the existing platforms for a service they're not even delivering yet. Remember, if they're using the combination optics, they can do both, but they're still paying for the higher speed service, even if they're not deploying it now. So that was interesting, because that's the model they're all moving forward with, is that so in the future, they can go ahead and upgrade a lot faster with zero touch than they could before. I think the same thing could very well happen with 100 gig. There's a lot of work that's being done right now on various implementations of 100 gig technologies. Infinera is one that's working on one. They're taking essentially using the economics of data center deployments, right? And the transceivers and optics, as data centers continue to grow, they push down the cost of those optics, which is why 25 gig is quickly becoming an option, is because most data centers use 25 gig optics, so the costs have come down tremendously. And I think the same thing could happen with 100 gig, so that you see, right after 2030, you see this uptake of 100 gig PON technologies in residential networks, which seems completely ludicrous at this point, but it's, like I said, it's going to get used.